Assalamualaikum. Today I will be presenting our project on the structural analysis of wall-mounted shelf bracket. This study focus on analyzing the structural behavior of a wall-mounted shelf bracket which is modeled as a cantilever beam. The bracket is subjected to uniformly distributed load from the shelf itself and the items stored on it. Hence, calculation are used in this analysis to evaluate key structural parameters such as bending stress, shear force, deflection, and the factor of safety. These parameters are important to determine whether the bracket can safely support the ply load without failure. The main object of this study is to assess the structural integrity of the shelf bracket and to ensure its suitability for safe daily use. Next.
Literature review. The behavior of a wall-mounted shelf bracket can be modeled as a cantilever beam subjected to a uniformly distributed load from the shelf and books. Maximum bending and shear occur at the fixed end, which is the critical section, by calculating bending stress, shear force, deflection, and factor of safety. We can evaluate the structural integrity and ensure the bracket is safe and suitable for daily use.
Problem statement and objective. Despite their simple appearance, shaft brackets may experience excessive deflection or even structural failure when subject to overloading or poor design, which can result in safety risks, falling objects, and damage to property. First, to model a wall-mounted shaft bracket as a cantilever beam subject to uniformly distributed load. Second, to determine the bending moment, shear force and deflection of the shaft bracket under actual loading condition using hand calculation. Next, to evaluate the maximum stress developed in the bracket and compare it with the material yield strength. And lastly, to determine the factor of safety the shaft bracket and assess its suitability for safe daily use.
So next, to ensure structural integrity, the maximum bending stress is evaluated at the fixed support, which serves as the most critical section of the bracket, using the fundamental flexure relationship. Additionally, a buckling analysis is conducted using Euler's formula, which is PCR equal to pi square EI over KL square, to verify that the bracket remains stable under compressive force and does not suffer from instability failure. Finally, the design sufficiency is validated through the factor of safety (FOS), which compare the yield strength of the material to the maximum stress caused by the load. This comprehensive approach ensures that the shaft bracket can sustain the intended weight with minimal deformation and maximum safety.
So next, this is the important part of on this project, which is calculation. The beam has a length of 800 millimeters and is fixed at one end with a load of 300 Newton per meter acting along the beam. From the free body diagram, the total load on the beam is 240 Newton and the reaction force at the fixed end is also 240 Newton. The maximum bending moment occurs at the fixed end and is calculated as 96 Newton meter. Using Euler-Bernoulli beam theory, the maximum deflection occurs at the free end and is approximately 18 millimeters. The beam is made of mild steel with a yield strength of 250 megapascal, and the maximum bending stress calculated is 133 megapascal, which is lower than the yield strength, indicating the beam is safe in bending. A buckling check using Euler's buckling formulas give a critical load of 3,330 Newton, which is much higher than the applied load. Therefore, the beam is structurally safe in terms of bending stress, deflection, and buckling. That's all from me, and thank you.
Next is discussion. The analysis show that the wall-mounted shaft bracket behave as a cantilever beam under a uniform load, which maximum bending stress and moment at the fixed support. The calculated stress is below the material yield strength, and the factor of safety indicates the bracket can safely support the load. Maximum deflection occurs at the free end but is within tolerable limits, and buckling is not a concern. Increasing the bracket thickness to 12 mm improve stiffness, reduce stress and deflection, and confirm that the bracket meet strength and serviceability requirements for practical use.
Conclusion: this project analyzed the load-carrying ability of a wall-mount shaft bracket, modeled as a cantilever beam under a uniformly distributed load. Maximum bending stress occurs at the fixed support but remains below the material yield strength, with an adequate factor of safety. Deflection is highest at free end but acceptable. Increase the bracket thickness to 12 mm, improve stiffness, reduce stress and deflection, and buckling is not a concern. Overall, the 12 mm shaft bracket is safe and suitable for the intended loading.